Now, if in the situation of the preceding, there are two forces acting, and one of those forces does negative 400 joules of work, for example, a frictional force opposing the motion, then how much work does the other do? Well, the previous situation, or the current situation actually, is one where the work done by the net force is 10,000 joules. So, the work done by the net force is the work done by all forces, the total. And that equals negative 400 joules plus the work done by the other force, because there are two forces. So work done by all forces consists of the work done by the force that does negative 400 joules plus the work done by the other force, whatever that other force may be. Meaning, and that the work done by the net force is also 10,000 joules. So the work done by the other force has to be greater than 10,000 joules to make up for the negative 400 joules that's being done against the system. So that the work done by the other force has to be 10,400 joules. Of course, you can set that as an equation, set this equal to this, which we've already done, and solve for the work by the other force. You're going to add 400 joules to both sides, and you're going to get the 10,400 joules. You pretty much get that just by common sense. What would you have to have here in order to make this come out to 10,000? You got to have 10,400, obviously. So, another important aspect of the application of the work done by a net force. It's the work done, total work done by all the forces. If you know the work done by the net force and you know the work done by all but one of the other forces, you can find the work done by that last force, and then you want to reconcile that with your intuition.